Lesson 34, Graphing Linear Equations, Part 2. A function that has a constant rate of change is called a linear function. So let's just put a linear function has a constant rate of change. A linear function is a line, a non-vertical line. Okay, so a linear function has a constant rate of change and is a non-vertical line. So when we see a graph that has a little bit of a curve to it, say like that, this is still a function. It passes the vertical line test, but it is non-linear. And then if you had just a straight line, this one is considered linear because it's not vertical. And there you go. There's three forms of linear equations. One is standard form. That's where you have ax plus by equals c. A, b, and c are real numbers, and a and b cannot equal 0. Or not both 0. A and b both cannot be 0. Then we have the slope-intercept form. Which is y equals mx plus b. M is the slope, and b is the y-intercept. And the third form is called the point-slope form. If you have one point and you know the slope, you can use that form to write the equation. Y minus y sub 1 equals m parentheses x minus x sub 1. M is the slope, and x sub 1 comma y sub 1 as a coordinate is a point on the line. If you know more than one point, then you can have a different looking equation for point-slope form. Just depends on which point you pick. It will be the same equation, just different looking. So if we're asked to graph a line in standard form, 2x plus 3y equals 6, you can start by finding the intercepts. So the x-intercept is when y is 0. So if y is 0, x or 2x equals 6, so x would be 3. So we come over, graph our 3, 0. For the y-intercept, it's when x is 0, so 3y equals 6, so y would be 2. And then you would connect the intercepts and you have your line. If you want to graph a line in point-slope form, I'm assuming that we've done slope-intercept form enough. I think I'm assuming that.
Yeah.
Yeah, so we're not going to do that one. But if you have point-slope form, super awesome. So we have point-slope form. graphing. So if we have y minus 3 equals 2/3 x plus 1. So we know that the slope is 2/3, and we know a point is at -1, 3. So if you know a point, you can graph that point and then just use the slope to find another point to connect to it. So -1, 3, and then the slope is 2/3. Because I can't go up 2 and to the right 2 without going into my writing, I'm going to go down 2 and to the left 3. That'll still be a positive slope. I'm going to go down 2 to the left 3, and then there's that. Oops, make it straight. There we go. And that's graphing in point slope. If it's in slope intercept, your point is on the y-intercept, then you do the slope to find another point to connect. We're going to talk about transformations of a linear function. Justin?
So when you're in point slope form, the x and y point that's in the form, they're gonna be opposite numbers. So like the x plus 1 is gonna turn into a -1.
Yes, yes. So in the point slope formula, because in the formula you have a minus y and a minus x, when you see the numbers, it's going to be like, it'll seem like the opposite. So the y was 3 instead of -3, and the x was -1 instead of 1. So
It's
yes,
always gonna be opposite.
yes, if it's in point slope form. So we are going to talk about transformations of f of x equals x. This equation of a line is called the parent function. Goes through the origin and has a slope of 1. So if we take the negative of the function, then it's a reflection in the x-axis. Whoops, that should be a C. If you add a number to the end of your function, it's going to be a vertical shift C units up. If you subtract a number, a constant, it's a vertical shift C units down. If you take a constant and multiply it by the function, it's a vertical stretch by a factor of C. If, and only if, the absolute value of C is greater than 1. So that just means a mixed number or a whole number. Even if it's negative, it'll still be vertically stretched. If it's negative, it'll just be reflected in the x-axis. And then if you have the same thing, C times the function of x, it's still a vertical, no, it's a vertical compression by a factor of C if the absolute value of C is less than 1. So that's a fraction smaller than 1. Vertical stretch is where you pull your, I want to show with my hand. Here we go. A vertical stretch would be making it skinnier. So you're pulling it up. A vertical compression would be making it, oh no, it wouldn't, because it's not a parabola, it's a line. So a vertical stretch, so, whoops, there's the parent function. A vertical stretch would be making it steeper.
Slope.
Yeah, it's going closer to the y-axis because you're pulling the y-axis, so it goes steeper. And then a vertical compression would be where it goes, so this is parent less steep. So you're kind of pushing it down that way. Yes?
So on there you have like the same equation
No, because it depends on what C is. So if C is greater than, or the absolute value of C is greater than 1, then it's a stretch. If it's less than 1, then it's a compression. Okay. If the slope is 0, then y equals 0x plus b, or y equals b. So that is a horizontal line. Through basically y equals b. So whatever b is, you put that on the y-axis and then draw a horizontal line. That's with a slope of 0. Have we done the car thing with the slopes this year?
Yes,
Okay.
yes.
This year. Okay.
Yes.
Justin?
So I tried plugging that into my calculator, like over y equals 5.
Mm-hmm.
It wouldn't show up on the beam. Okay. Tried messing with that. I'll just
It might be your dimensions. Yeah, we can look at that later to see. Tally?
So on the c times f of x, what if the absolute value of c is 1?
Then it is just the
It's
function.
like
It doesn't
y equals
move. So like if we had f of x equals x, if you have a 1 times f of x, you just get the function itself. So it would stay the same. So it wouldn't move at all. Kind of?
I got it.
Still not making sense, Tally?
No?
It does? Okay. If you have an equation x equals b, this is still a linear equation, it's just not a function. So it's a vertical line with an undefined slope. And it's not a function. Okay, that's it on notes.